Good morning, everybody. Hope you're all okay. Well done for all your hard work yesterday. Had some fabulous pieces of work sent in to us. We're moving on today in a similar form, but this time we're looking at division by 10, 100 and 1,000. Before we do that though, we're going to start with our Fab 4. So make sure you're armed with your scrap paper and a pen or a pencil. I'm having a recap looking at ordering fractions today. Now, when we're looking at ordering fractions, what's the thing we need to think about? What has got to be the same before we are able to order them? The denominator. So you have got to, before you order these, convert fractions, so they all have the same denominator, then reorder them. Now, for my answers, I've put them back to their original form. So you might want to make sure you do that for yours so that you can mark them against the ones that I've put there. So you're going to convert, order, check, off you go. 4 minutes. Come back after 4 minutes and I will show you the answers. Okay, well done. So hopefully you've had a go. Here are the answers in the correct order. So just look through. I've put them back into their original form. So you might need to have a look through that. By all means, feel free to pause the video here if you want to have a look at those answers. And then we're going to move on to what we're doing in Power Maths today. So today, our WALT, we're going to be this time dividing integers by 10, 100 and 1,000. So like the inverse of yesterday, we're still focusing on 10, 100 and 1,000 as our divisors, but we're looking at division rather than multiplication today. Now for our WILF, we're going to be able to use a place value chart like yesterday, but this time we're shifting the digits to the right to divide, because obviously when we're dividing, our numbers get smaller. And sometimes we're going to look at how we might need to use a placeholder where you've got gaps in our chart. All right. Okay, so our Discover for today. We have got a classroom here and Mrs. Dean is in charge of making some paper chains. Now she wants to make 12 meters of paper chains and she wants 10 children to help to do this. Now, first question then is, if they're making 12 meters of paper chains and they all make an equal length, what length does each child make? So my first question to you then would be, what is the calculation that we're doing here? If we've got a whole long length of 12 meters and 10 children are each making an equal amount, how are we going to calculate what length each of them make? Have a little think. What's the calculation going to be? There it is. We've got to do 12 divided by 10. Now yesterday, when we were multiplying by 10, we knew that if we times by 10, all of our digits moved into the next box higher because our number needed to get larger because we were multiplying. So we were exchanging into the next door box. Now today we're dividing. So when we divide, unless we're looking at a decimal number, our numbers will always become smaller. So this time they're going to be moving into a smaller space and they're going to go, if we're dividing by 10, we're moving one place down, or we're exchanging into the smallest part. So let's have a look what this might look like on a place value chart. So here's our place value chart. We put 12 in our correct column. Now if we're dividing by 10, we know we're going one place smaller. So that means everything's going around the decimal point, because remembering from yesterday, that doesn't move. So it's going to look like this. So 12 divided by 10, 2 exchanges into the tenths, the 1 exchanges into the ones, and our final answer then is 1.2. So a little bit like the same as finding out something times 10 equals 12, but it's just the inverse. Okay, so the inverse means the opposite. So when that means 12 divided by 10 would be 1.2. So 1.2 multiplied by 10 would give us 12. There are sort of pairs of calculations that would match one another if we looked at the inverse. Okay, now this time for our Discover, we've now got 20 children in the class and they're still going to make a length of paper chain that is going to total 12 meters. So how would we decide the length of paper chain this time that each child will make if there's 20 of them? Now my first question is, How can you use what you already know from your answer to question 1? Now in question 1, we divided by 10 because we had 10 children. So our calculation this time is 12 divided by 20. Now in my maths group, and I know you've probably done this in the other groups as well, we talked a lot about using our factor pairs to divide by slightly larger numbers. Now, obviously, if we looked at factor pairs for 20, there are quite a few, but I want us to remember that our WALT is to divide by tens, hundreds and thousands. So let's think about the factor pairs for 20 that involves maybe a 10. So we're dividing by 20. We know that 10 multiplied by 2 gives us 20. So that's a good factor pair that matches our WALT today. So how would that look? Let's see. Let me move myself out of the way. So let's use the inverse of that factor pair of 10 multiplied by 2 equals 20. So the first step would be to do 12 divided by 10. Okay, now it doesn't matter which way round you do this. If you want to divide by 2 first, that's fine. I've just done it by 10 on this example. So if I divide it by 10, I know that that's going to give me an answer of 1.2 because everything's moved one space smaller like we did in question 1. Now, then we think about it by dividing 1.2 by 2, because that's the other part of our factor pair of 20. So how's that going to look? So basically, I'm halving, aren't I? 1.2, I'm dividing it by 2, which gives me an answer of 0.6. So if I want to do my calculation of 12 divided by 20, I know that my final answer is 0.6. I've just got an extra step to if I was dividing just by 10. So each part of the paper chain that each child is making this time is 0.6 meters. So it's halved really the answer, hasn't it, that we did when there were only 10 children there. Now we can use this if you are dividing by multiples of 10. You can do it into 2 stages. So you could divide by 10 first, and in this case, then we divided by 2. So if we were to divide something by 30, we could divide by 10 and then divide by 3. Our factor pairs of 30 would be 10 multiplied by 3. In your Power Maths today, it does go into this a little bit more. So it might be good to have a little practice, or if this is a bit confusing, go back over this slide again if you need a little bit more work on it. Now, think together. So this time, Aki has got 15 litres of juice and he's got 100 cups. So the calculation is 15 divided by 100. Now, first question is, when you divide by 100, how many places to the right do the digits shift this time? So remember my tip from yesterday, if it's divided by 100, it's got 2 zeros. That means it's shifting 2 places and we're dividing. So again, we're going smaller. Now I'm going to see if I can get my pen on here. Just give me a minute. So here we go. Now we've got 15 in our place value chart. This time we're moving 2 places smaller. I've just realised I've got white. That's not going to work. Black. So my 5 is going to jump around the decimal point. Now if I divided by 10, it would stop in the tenths, but I'm dividing by 100, so it's got to go another place smaller. So the 5 would come here into the hundredths column. The 1 is going to jump 2 spaces. There goes 1 around the decimal point. There goes 2, and so my 1 is in the tenths column. Now, one of the vocabulary words that we looked at was a placeholder. Now, if I just wrote this into my answer box here, it would look like the answer was 15 again. However, I've got to remember that I've got my decimal points here, and I don't just write 0.15. In my ones column, I've got to put my placeholder of a 0 here. So actually 15 divided by 100 is 0.15. That 0 is acting as a placeholder to show that there is nothing in the ones. Don't need to go into the tens and the hundreds. It doesn't happen. But in this case, you need to have 1 in the ones. So your answer would look like this. 15 divided by 100 is 0.15. So Aki will pour 0.15 litres of juice into each cup. If you want to stretch yourselves a little bit, I want you to have a think about what he's saying here. I wonder if I'll get the same result if I convert into millilitres first. So if you want to challenge yourself, you could pause the video and have a little think about that. How would it work if I converted into millilitres first? Okay, quite a lot to take in there. Now it's time for you to have a go in your Power Maths books. So you're going to turn to pages 9 to 11 today, and you're going to look at the title, Dividing by Multiples of 10, 100 and 1,000. Like you did yesterday, have a go at working all the way through the book, see if you can get all the way to the reflect. Take some photographs, send it in to me, and I shall get back to you with some comments, and hopefully it will all be perfectly clear. Now, if you get stuck, please do send me an email. Sorry, not an email, we're using Dojo now, so send me a Dojo message and I can help you with any bits that you get stuck with. But I think you'll be absolutely fine. And if you get to all the way to the end and you want to really challenge yourself, have a look at this challenge, come back to the video, pause this page, and you can have a workout on this part here. Now, we sent home some exercise books, so you could complete that in your exercise books. If you want to take a photograph of it and show me, I'd love to see it. All right, have a wonderful day, and I will see you again tomorrow for lesson 3. Okay, bye-bye.